This is Chemistry 1, Unit 4, Lesson 1 on electrons. And in this video, we're going to look at this summary chart that puts everything together with valence numbers, dot diagrams, and ion notation. So you are going to need your numbered Flynn scientific periodic table elements that has the numbers at the top so we can look at this and use it. So what we are going to be talking about are these groups. Remember that a group is a column on the periodic table. So we're going to look at group 1, 2, and then 13 through 18 on the periodic table. So their numbers are here. So we're going to go ahead and number that 1, 2, and then 13 through 18. So we're just going to pick one element from this column, and then we're going to talk about how many valence electrons, what its dot diagram would look like, and we're going to use X for the element. We're going to write down if it gains or loses electrons, how many it gained or lost, what charge it would have, and then the ion notation. And we're going to use X for the element symbol. So for group 1, if we just pick one of those, it doesn't matter which one you pick. I'm going to pick sodium. And everything in that group has one valence electron. So its dot diagram is going to look like that. So we could substitute hydrogen, lithium, sodium, potassium, rubidium, cesium, or francium, and they would all have the same dot diagram. Now, remember that gain or loss is based on how close it is to 8, either 8 for the level underneath it, or if it's closer to 8 with the number of valence electrons it has, it gains it. So this only has 1, so it is going to lose 1 valence electron. So if anything loses, it loses all of them. And when something loses, it becomes positive. So we're going to have ion notation, a positive 1 for everything in that column. So group number 2, I'm just going to pick another one. Let's say that I pick calcium. Calcium has 2 valence electrons, so it has 2 dots in its dot diagram, as does everything else in that column. It also loses, but it's going to lose both of them, so it loses 2. When something loses, it becomes positive. So we're going to add the symbol of that element and a positive 2 for its ion notation. Okay, group number 13. Group number 13 is going to be starting with boron down through nihonium. So let's just pick something easy like aluminum, something that we're familiar with. Well, we wrote a big 3 above there, so it has 3 valence electrons, so it's going to have 3 dots in its dot diagram. It's also going to lose because, remember, 4 was our turning point. Everything 3 or less is going to lose. So it loses all of them, becomes positive, and now is going to have a positive 3. Now group 14 is our switching point. Carbon is a good example of an element in group 14. It has 4 valence electrons, so first 2 get paired together, and then they start separating out. This one could go either way. It could lose or gain. But the number is going to be the same. It's either going to gain 4 or lose 4. So if it gains or loses 4, we could have x plus 4 or x minus 4. Either one works for that. Group 15. Here we have nitrogen as an example. It has 5 valence electrons. So the first 2 get paired together, then 3, 4, 5. It's going to gain electrons. It's easier to gain 3 electrons to make 8 than it is to lose 5. So it's going to gain 3 electrons. If it gains, it becomes negative, and it's going to be minus 3 in charge. Oxygen is a good example for group 16. It has 6 valence electrons, so it has 6 dots in its dot diagram. So 3, 4, 5, 6. It gains, well, it wants 8 and has 6, so if it gains, it needs to gain 2 and becomes -2 in charge. Group 17, fluorine is a good example. It has 7. Fluorine, if it has 7, it only needs 1 more electron to be stable. So it gains 1, becomes negative, and is -1 in charge. And then finally, group 18, those noble gases that we talk about. So a good example here would be xenon. It has 8 valence electrons. So it's going to have all 8 surrounding it. It's going to be stable. It doesn't gain or lose. It remains neutral. So we can write it like that. So this chart is going to be very helpful for us for the next couple units because we're going to apply what we learned here.